Hello everybody, welcome to another video in which I try to explain physics as simply as possible but not simpler. This is the first video in the series where I will show you how to solve the problems related to uniformly accelerated and decelerated motions. You should be familiar with the basic theoretical background of this topic, which I explained in this video. So check it here and in the description of the video. And also I invite you to check the level 1 videos on this topic to have the basics. Now we move to solving the problems, and in next videos there will be even more advanced, maybe more interesting problems. So now we focus on the case of the car, which accelerates from the initial speed 18 kilometers per hour to speed 72 kilometers per hour, and it makes it at the distance of 600 meters, and the question is in what time it makes it. So first of all, I would expect to have the result in seconds, and also here I have kilometers and here I have meters, so I should convert these speeds from kilometers per hour to meters per second. So let's call the initial speed v1. So this is 18 kilometers per hour, and as I explained to you in previous videos how to convert the speed from kilometers per hour to meters per second, I multiply this, so kilometer is 1000 meters, an hour is 3600 seconds. I reduce this fraction, so I multiply like this, and also 18 reduces with 36, so eventually I get 10 divided by 2, so this is 5 meters per second. And final speed of the car after this 600 meters was v2 72 kilometers per hour. So you know from this that this is 72 times 10 divided by 36 meters per second, and numbers are nicely chosen so that you can also reduce 72 with 36, so it's 2 times 10, so it's 20 meters per second. All right. So it's easy to see from this that the change in speed is v2 minus v1, so it's 20 minus 5, so it's 15 meters per second. Okay, so we have uniformly accelerated motion. We know the speeds, change in speed, and we know the distance. We need to calculate the time. So first of all, formula for the acceleration is change in speed divided by time. So I know what is change in speed, but we don't know what is acceleration and we don't know what is time, so we have two unknowns in one equation, so we definitely need second equation. Second equation can be another equation discussed in this topic, so distance in uniformly accelerated motion. So distance is I remind you, initial speed multiplied by time plus 1/2 acceleration time squared. And in our case, initial speed is called v1. So here let's put v1, and it's nice because distance we know, v1 we know, t we don't know, but it's our unknown, a it's second unknown, and t we don't know. So now we have two equations or system of two equations with two unknowns. So because we are looking for time, it's convenient to plug in this here for a, then the only unknown in this equation will be time. Okay. So let's rewrite it. So distance is v1t plus 1/2, and instead of a I write delta v over t times t squared. So t reduces. So we have like this. We can see that t is a common factor, so it's like this. And now you have two options. You can work on these symbols, on letters, or you can plug in values right now. I will first work on symbols and then show you second approach when you here plug in the values. So you want to calculate time because it's our unknown. So let's divide the both sides of the equation by this bracket. So you get that time is s distance divided by what is in bracket, so v1 plus 1/2 delta v. And now we can plug in numbers. Look, distance we have, v1 we have, delta v we have everything. So distance is 600, v1 is 5 plus 1/2 times 15, so this is 7.5. 7.5. So this is 600 divided by 12.5, and if you calculate it using calculator, you get that the result is 48 seconds. Everything is nice because here you have meters, here you have meters per second, so the result is in seconds. And second approach, from here you plug in numbers, so you have distance 600, in bracket you have what? You have v1 5 plus 1/2 delta v, so 1/2 15, so this is this 7.5 times t, so this is 12.5. So then you divide by 12.5 and you get exactly, you are exactly here, and of course you will get the same result. So this is how to solve quite simple problem related to uniformly accelerated motion. If you have questions, please ask in the comments, and I invite you to my next videos, in which I will show you how to solve even more advanced problems.